Hi, my name is Prakash Gupta, and this is my Physics 2212 Lab 1 video report. So the main physics concepts that we covered today included Newton's laws, which, are prevalent throughout the course of all physics, the electric forces, charges, and repulsion between like-charged items. So let's talk a little bit about the experimental setup and calculations. So as we know that this lab involved setting up some interesting pieces of tape, applying charges to them, and looking at how they interacted with each other. So the length of the tape used was about 20 centimeters. I measured to this because it's approximately equal to 8 inches, but it's a much easier number to work with for calculations because it's in metric. The mass of the tape was 20 centimeters times 100 centimeters per meter, which I divided by 100 centimeters per meter, times 1 gram per meter, times 1 kilogram per 100,000 grams, or sorry, 1,000 grams, which tells us that our total mass was 0.0002 kilograms. Now, here's so the distance measured between the two tapes was 0.05 meters, which is approximately 2 inches. But there's an asterisk there, and that's because this is the major source of error in this experiment. I had a lot of difficulty getting the tape to kind of suspend in a way that was consistent enough to take a measurement. So that's kind of like an average, and it's also kind of based on the um, imagery and what I thought that the lab was supposed to turn out. So that's an assumption that we're going to use for the rest of the lab. So now for some calculations, we find the gravitational force, which is just going to be the gravitational constant near the surface of the Earth, times that mass, and that tells us that it's 0.002 newtons of force. We know that theoretically, since the electric force is holding our tape in stasis against the gravity, they're canceling out by Newton's second law. So we should find that the electric force is going to be equal in magnitude to the gravitational force, but in the opposite direction. And this tells us that the measured electric charge is that number there, and we can dig into the calculation for that because it's going to come up again in our programming and simulations. Moving right into those, you can see the two simulations. So we had two again, of course, which are the single point charge, where we consider each piece of tape to be 1 point charge, and we have the line of point charges. So and you can see at the bottom corner there, we have the GlowScript model that came about from that. And at the top, we have a slightly bugged GlowScript model from the line of point charges simulation. So you can see on screen the magnitudes given. And you can also see the code from which we derived the single point charge magnitude. And I'm going to walk through that just a little bit. It's mostly just the calculations that we discussed on the other side, but I want to highlight how we find the value of Q given our found force of electric force. So we wanted to solve that algebraically. We know that the electric force on a point charge is 1 over 4 pi epsilon naught, or epsilon 0, times the product of the charges divided by the radius between the locations squared. And we know that we can solve algebraically by multiplying by 4 pi epsilon 0, or multiplying by 1 over that number. And then we can take that magnitude, which is the radius, and we can square that. And then we can we can multiply all of that by the magnitude of the force, and that gives us Q squared. When we take the square root, we get our charge Q out. And note that there are a bunch of assumptions that we're making throughout this. And one of the main ones here is that the charges, well, obviously for the point charge, that we can treat each tape as a point charge, and separately that the force is evenly distributed throughout the tape. It's a fair assumption as well that each tape is identical, and that they have the same charge because they were created and prepared in the exact same way. Regarding the line of point charges, the key difference in assumption is that we're treating each tape as a line of point charges as opposed to one. So now let's talk a little bit about what if and why. So what if the charges of electrons and protons were totally swapped? And the answer to that, nothing would happen in this case because there's a symmetry between positive and negative, which is portrayed throughout the, like universe. And basically that's like the same thing as asking what happens if we swap the label on positive and negative. And labeling doesn't really do anything. So nothing would happen if we made this swap. We can see in terms of the experiment that we did, if we make this swap, nothing would happen because positive charges would still repel each other and we would still have the same experiment come out. So talking about why, comparing the estimated values to the experimental data, why would they be different? We talked about this a little bit already, but the point charge model is using a much stronger simplification and assumption. Like on top of all of the other assumptions that we have throughout, we're condensing this long physical object into a single volumeless point charge. So that's going to be less accurate than the other one simply by nature of the fact that the assumption is stronger. But thank you for your time, and this is the lab report.